This lesson is about functions and inverse functions. Our objective is to verify when we have a function if it's the inverse of another function. So let's start off talking about inverse functions. If I've got a set of ordered pairs, I can check to see if it's a function by checking the inputs, which are the x values, and seeing if those values are ever repeated. In this case, they're not, so this is a function. Then, if we want to check to see if it's one-to-one, we look at the y values. And if the y values are ever repeated, then it's not a one-to-one function. Since none of these repeat, this is also one-to-one. If we have one-to-one functions, we can take the x and y values of a function, swap those values, and we'll still have a function. Those are called inverses when we swap the input and the output. Let's take a look at this this set of ordered pairs. To find the inverse, it's just the simple process of swapping our x and y values. So you just go to every ordered pair, switch the x and the y, and this is our inverse, where the input has become the output of the inverse, and the output has become the input. They're swapped. Now, when we're doing it with a formula, the next step to do is to learn how to change places here with the x and y. First, we got to change the notation. So this f of x, we're going to, as a first step, make it y equals. Now, once we've done that, the process of finding the inverse is just taking the x and the y letters and having them switch places. So you can have x equal to 2/7 y plus 5. Now we've got to get the y by itself. So we're going to subtract 5 from both sides. And now to get rid of that 2/7, you multiply by its reciprocal. So we multiply both sides by 7/2. Make sure you do this on this side, make sure you do it to the entire side by putting it in parentheses. So this will be by 7/2. So when you have 7/2 x minus 5/1, you get 35/2 equals y. So now what we have, this formula is our inverse function formula. We rewrite it with this notation. We put a -1 up here. That doesn't mean an exponent -1. It means it's the inverse. And so we have equal to 7/2 x minus 35/2. That's our inverse of this function. Now, what if we want to verify, if we've got two functions and we want to say, are these two inverses of each other? Well, there's two methods for doing that. So the first method, method 1, for verifying if these two functions are inverses, just looking at them. Method 1 is if you find f of g of x, you do the composition of the two of them. If the very inside input becomes the output of the composition, x, and you do it the other way around as well, as a composition with the other function being the input, if you get x for both of those, you have verified that it is the inverse function. Now you do have to do both. Method 2 is all you have to do is do like we did above here, is if you take the original function and you find its inverse to verify it's the other one. So find the inverse of the function and verify it's the same as the one you're trying to show is the inverse. Okay, so I'm going to show both of these methods. I'm going to start looking at this with these two down here. I'm going to do the f of g of x, doing our composition of functions. So for f of g of x here, this means you're going to take the g of x function and put it into the f function. So where there's an x, I'm going to put a parentheses. I'm going to put this inside of it. Now just simplify. So you get 3 times 1/3 x is just x, 3 times -3 is -9, plus 9 equals just x. Notice the composition of functions just gives me that very inside input becomes the output at the end. Now let's do g of f of x, because you do have to do both and you have to show it. This is verification, so you gotta show your work on it. So now I'm gonna take this function and put it inside that one where there's an x. So I'm gonna take and put a parentheses where there's an x there. And now put this inside, so 3x plus 9. And now when I distribute through, I get 1/3 times 3x is just x, 1/3 times 9 is equal to 3, minus 3 is just equal to x. So we can put that that's verified. Those two are inverses of each other. Now the other way to do it, the second method, is if you just take one of these and you try to find the inverse of it. Now I'll show it on this one just to guarantee how this one does work out. So this is method 2. I'm going to take this one, make it y equals 3x plus 9. And now I'm going to take this and take the inverse by swapping the x and the y. X equals 3y plus 9. Subtract 9 from both sides. And then multiply both sides by 1/3, and you get 1/3 x minus 3 when you distribute through that 1/3. That's exactly what our second function is. We verified it this way with f of g of x and g of f of x. That's method 1. Method 2, find the inverse and verify that they're the same. Let's try this one. If we do this one, again, if we're going to do f of g of x, let's take the g of x, and we're going to put it in for x in the first function. So you're going to put in a parentheses into that formula, put in the 1/4 x minus 20, so that becomes the input. Now distribute through, so 4 times 1/4 x is just x, 4 times -20 is -80, plus 20, when I simplify that, I get x minus 60. I don't get f of g of x equals x, I get something extra. You don't even have to do the g of f of x when one of them shows that it doesn't work. So this is not verified. They are not inverses of each other by looking at that process. Now method 2 would do the same thing for us. If we did method 2, what you do is you take one of them. I'll take the first one. I'll make it y equals 4x plus 20. Swap the x and the y. That's our inverse process. So taking the inverse of it, like we learned up above. Now we swap them. We get x equal to 4y plus 20. Subtract 20. Divide by 4. So what you get, or multiply by 1/4. You get 1/4 x, -20 divided by 4 is -5. That formula is not the same as the second one. So that shows you that it's not the inverse. So if you have a one-to-one function, you can swap the x's and y's and find its inverse. If you want to verify given two functions, if they are inverses, there's 2 methods you can do it. Find the formal verification method is to find f of g of x, and if it gives you x, and g of f of x also gives you x, then those are inverses. The second method is to just take one of the 2 formulas, find the inverse, and verify that it's your second function. This will help you understand how those two, the function and its inverse, interact.